The Periodic Table by Grace Anderson. It is important to know that one person did not solely develop the periodic table. Even though Dmitri Mendeleev first presented it, the scientists who discovered each element are equally as important. The people's names, Georgius Agricola, Hans Jacob Berzelius, Marie and Pierre Curie, and Humphrey Davy, all helped to contribute the periodic table with their findings. Dimitri's book was finally published in 1886. This book was called The Principles of Chemistry. In this book, I found a quote. Mendeleev noticed patterns in the properties and atomic weights of halogens, alkali metals, and alkaline metals. When Mendeleev arranged the cards of the known elements on a table in order of ascending atomic weight, grouping elements of similar properties together in a manner not unlike the card arrangement in his favorite solitaire card game, Patience, the periodic table was formed. Indeed, it appears that Mendeleev may have been able to make for progress than some of his contemporaries, who were also developing periodic systems, because of his psychological ideas about the nature of the elements. It is safe to say that Mendeleev took great responsibility in developing the periodic table. The elements of the periodic table are made of atoms which we see everywhere around us. An element has already been broken down as far as it can go. The atom's electrical charge determines whether electrons are gained or lost. Inside the atom, protons carry a positive electrical charge and electrons carry a negative electrical charge. The elements on the periodic table are grouped by metals, nonmetals, and metalloids. First, we have the metals. Metals are malleable and are shiny, opaque, and good conductors of heat. Since metals are malleable, this means that the element is capable of being stretched or bent into different shapes, or capable of being easily changed or influenced. Examples of metals include mercury, hydrogen, gallium, and francium. Right next to the metals on the periodic table are the metalloids. These metalloids are semiconductors, which means they are a material or object that allows some electricity or heat to move through it, and that it is used especially in electronic devices. They are also weak conductors of electricity. Examples of metalloids include boron, silicon, arsenic, germanium, and antimony. On the far right of the periodic table are the nonmetals. These nonmetals are poor conductors of electricity and heat and may also be transparent. Examples of nonmetals include helium, carbon, and bromine. Each element on the periodic table has its own individual box. Each box contains the element's number, symbol, name, and mass. The element's atomic number is located in the center of the top of the element's symbol. The atomic number of an element is the number of protons in a given element. The modern periodic table lists the elements in order of increasing atomic order. The atomic symbol of an element is an abbreviation of the element's name. Most of the time, the element's name is written below this symbol. Located at the very bottom of the element's information is the element's atomic mass. The atomic mass is the sum of the mass of all of the atomic's components, electrons and the nucleus. The periodic table is identified by periods and groups. Each horizontal row is called a period. If a person starts at the beginning of a period, the far left, they will notice a gradual decrease in the properties of the element. This change is called a periodic trend. Next, the groups of a periodic table are the vertical columns. Down any group, the properties of elements tend to be remarkably similar, which is why these elements are said to be grouped or in a family. Alkali metals, alkaline earth metals, transition metals, halogens, and noble gases are all groups of the periodic table.